Okay, hi everyone, I'm Guy. I'm the founder of SCRT. SCRT is generally a privacy-preserving smart contract blockchain. Essentially, it's your run-of-the-mill Cosmos chain with CosmWasm, but the key differentiator is that users can encrypt inputs, state can be encrypted, and outputs can be encrypted. So essentially, you can do all kinds of private computations. If there's one message that I think people here should take, is that privacy, in my opinion, and I've been in this for like a decade, is very misunderstood. So usually when you talk about privacy in Web3, it's always a discussion about how to do private transactions, how to do anonymous transactions, how to hide your IPs, all like the conversation before me. These are all very important problems. But the problem is that when people think that this is all what privacy is about, it limits the discussion. So anytime I go like on a podcast, on a Twitter space, it always gets into this box of, should we allow people to anonymize their transactions, their IPs? What is the importance of protecting your own data? And how should we deal with regulators? Again, a very important discussion. I'm sure like half of the day would be about that. But I want to say that privacy extends it goes way deeper than that. In Web 2, we just assume that we have privacy. We just assume that it's built into our applications, at least in some form. Yeah, the big companies hoarding our data, but it's not that the whole world can probe in and see what we're doing. And in practice, if you think about Web 3, because everyone can see the data, there are many applications that we can't see, that we can't do today. Think about all kinds of games, casinos, poker, strategy, PvP games. All of those require some kind of hidden state that is segmented between the players. If you think about sealed bid auctions, generally people don't care about the privacy of their auctions. No regulator will come on board and say, oh, your bid was private, that is like, your money laundering. That's not the discussion. You need to do sealed bid auctions because they're more efficient, especially if we're going to start having things like MEV markets and all that. And there are many, many more use cases. And at SCRT, really what we're trying to focus on these days is basically making it clear that these are the use cases that we should focus on. And with this kind of like umbrella thing called privacy as a service, we're basically trying to externalize it beyond SCRT. Like you can do all of these on SCRT today, but it's less interesting. I mean, SCRT is a limited ecosystem. Cosmos is a much bigger ecosystem. EVM is a much bigger ecosystem. And those are really let's say, the domains that we're trying to kind of penetrate with this privacy as a service concept. Now, I'm not going to talk about all use cases. I'm actually just going to talk about one, which is more of a passion research project of mine that we launched this week. And I'm slightly going to touch a second one as well. So the first one is going to be Unstoppable Wallets. There's a research paper, if you want, I can give you the link. It went up, or just go on ePrint. It went up on ePrint yesterday. And then the second thing is basically on-chain randomness. And there are many ways to get randomness today in blockchain, but all of them are off-chain, and via SCRT you can do it on-chain. So let's drill deep into Unstoppable Wallets. So wallets in general, I'm sure everyone here knows that, they're essentially private keys. You use a private key, you sign a transaction, blockchain has a public key, you can either move your funds, send them to someone else, use a contract, do something, some operation, or you cannot. But that is also a single point of failure. If you lose your keys or if someone takes it, you're done. There's this then idea of, okay, let's let's not have like one honeypot, let's spread it around. Let's have a multi-sig wallet. How many people are familiar with MPC wallets here? Okay, so multi-sig wallets, how many people are familiar with that? Okay, so I guess I'll explain both. Multi-sig wallets are very simple. Instead of one person controlling the wallet, you have a group. It can be 8 out of 10 people, 5 out of 7, 1 out of 2, whatever you want to do it. MPC wallets are the same. They're a bit more technically sophisticated, actually much more. They have some benefits. The biggest benefit is that they're usually cross-chain. So whenever you have a multi-sig implementation, you have one for Bitcoin and the forks, you have one for EVM, and that's usually a smart contract and the forks. You have a different one for Cosmos, and each chain basically needs to roll out their own. When you do it via MPC, multi-party computation, you basically are building something that can go on any chain. The problem, and by the way, MPC wallets are generally winning the game. So like companies like Fireblocks, now Coinbase, all of those companies are basically, they're moving to operate in this way. You have the service provider here. They have like, one of the keys, and then you have one or more users that are co-signers. And that's how you get more security. So let's say I'm a company. I can sign up to Fireblocks. We generate this MPC wallet. They get half of the key. I get half of the key. Or I can do things like I have one half of the key, and they will co-sign with me for any transaction that is up to like $10,000. And then maybe there are 3 out of 5 people in the organizations that are able to sign on transactions that are higher than that. So the service provider acts as both a co-signer, but also as this like policy engine. Now, the problem with this model is that there's still a lot of trust in the service provider. So it's not as bad as like, going on a centralized exchange and using that as a custodian. But, and obviously the service provider cannot steal the money because they only have access to half of the key. And it's obviously more secure from the user perspective because now, even if the user is breached, there is like another service provider. But if that service provider is out, then you lose access to your funds unless you have a backup. They are usually operating in closed source. If you've worked with these companies, it's very hard to add like new assets and new features. Like it's really more of an enterprise kind of Web 2 solution, not really the kind of like open platform that we want in Web 3. And what we did with Unstoppable Wallets, essentially, we took the service provider part and we put something that is much more familiar to people in the space. A blockchain, smart contracts, and now half of the key sits with basically the blockchain, with the validators, and you can split that across the validators as well. And then there's a smart contract which you can program, and you can now start to basically program on-chain wallets with whatever functionality that you want. And obviously, as long as the blockchain lives, like there's no situation where the blockchain goes offline and you lose access to your funds. The problem with this approach that we had, and it almost killed it, is that MPC requires pretty heavy-duty cryptographic building blocks. And we looked at all of the threshold ECDSA, basically the MPC algorithms to do this kind of thing, and we tried to extrapolate how that would run on chain, and it would completely break our network or any Cosmos network or any EVM network for that matter in existence. It's just too expensive, it won't work, so we did the kind of stupid in retrospect thing of actually building our own algorithm and running our own. It took us a while, but after a few months we actually got something which is very, very useful. So we built a new threshold ECDSA protocol that is on-chain friendly and that can run inside of a smart contract. If people here are from like the ZK area, I like to correlate this. Like this is kind of like analogous to how in ZK, it's very, very inefficient to use like normal symmetric ciphers or hash functions. So there's this effort to build like ZK prover-friendly hash functions. So this is in a way similar. Like it's very, very slow to run this kind of cryptography on chain. So we had to kind of, with that in mind, come up with a solution that is friendly on chain. It also has other benefits like robustness and fairness. Basically, it's much more resilient than usual multi-sig wallets. And to be clear, this is not for secret, or this is not just for Cosmos. This is meant to basically be a cross-chain mechanism to sign and control wallets on any chain. The best analogy here is that Unstoppable Wallets are kind of like a building block to do cross-chain account abstraction. So account abstraction is this idea of smart contract wallets on Ethereum. Here's an idea how you can do something that can work on Ethereum, Solana, Cosmos, Secret, whatever you want. And this is an example where we basically have a smart contract wallet on Secret, but you sign it with, you sign transactions with it on Ethereum, and that was the first example where we got it to mainnet. All right, so I think one point to drive home is that these smart wallets, they're programmable completely. And we think there are many use cases that you can build and use them for, and we implemented two. One of them is obvious, and the other is less obvious, just to show that their expressible power. So the obvious one was to do basically a multi-sig wallet. So you need 5 out of 8 people, 7 out of 10, whatever you define when you launch the wallet. But you also have a spending limit. In this case, we put, like, just as an example, like a 1 ETH spending limit. So basically, when you try to sign a transaction, when users are trying to sign a transaction, the contract verifies that they get enough signatures and that it actually parses the Ethereum transaction, and it would only co-sign it if it's less than 1 Ethereum. And you can, come up with schemes that are much, much more elaborate than this. But I think the cooler use case, because that's not something that people think of when they see this for the first time. We didn't think about it when we started it. In crypto, we always operate in this scenario where we move assets. We don't move private keys, we don't move wallets. It's always that those are static, and you move assets from one wallet to another. But there are many use cases in many markets that actually operate on the wallet level. They don't operate on the asset level. So if you think about things like, if you lost money in FTX, right? And you have a claim. And now there's this trust, like pen and paper based, like over-the-counter markets where people are selling their claims. Basically, they're selling their claims to get some immediate liquidity. What if you could find a trustless way where I could actually sell my wallet, which may have eligibility for like an FTX claim, in a way that I probably revoke my access to that wallet, and the buyer gets it. And with this mechanism, you can actually do that. Another use case is VCs. Often VCs buy into like SAFTs and illiquid deals. And again, there's a huge over-the-counter market for that. So again, if like a VC wants to get out of like an illiquid position, they can here use this mechanism to sell their wallet and not their assets. There are many other use cases for this. I think the point is to get developers to actually try to think what more can be done. One less example, which we didn't develop, but I do want to touch on, is what I consider unruggable DAOs. In my opinion, one of the biggest shortcomings of DAOs today is that at the end of the day, holders vote on whatever, but usually the actual power, the actual treasury and funds, it resides at a very, very small committee of several people. And those people can technically listen to the DAO or not. They can do whatever they want. So what if you can have a smart wallet like this, where there are specific rules that the community sets in the smart contract on how the DAO can actually spend their funds. And maybe this is being composed with another contract, a voting contract for the DAO, such that if ever, for example, the DAO wants to do something bigger, like maybe make a really big spend that requires the entire vote of confidence from the community, so maybe that contract basically absorbs information, like voting results from another DAO voting contract, and only if and only when that happens can the multisig actually spend the funds in that way. One less detour, because this is probably of separate interest. Like we had to put fairly deep cryptography into COSMWASM and into Secret to make that happen. One of them was put in additively homomorphic encryption, which basically gives you the ability to do certain operations over encrypted data on chain, but not all of them. A, this is a first, but B, I think this has potential and use cases that go beyond just what we're talking about today. Like one example, you can do encrypted voting contracts using this mechanism, completely irrespective to the wallet thing. And the last point I'm going to touch is everything I talked so far is like there's code samples, there's research, backing it, security proofs, all that, but it's more or less POC and research level. This is This is different. So this is basically something we deployed in mainnet a few weeks ago. We call it Secret VRF. It's simply a way to consume randomness to your application or your chain in a very unpredictable way and do it on-chain. There are off-chain solutions to do this, but this is the first on-chain example. And right now we have APIs to all other IBC and Cosmos chains, and we're working on an EVM version as well. So yeah, I'll open up for questions. Most important takeaway message is privacy is not just normal, it's not just important, but it's really also useful. Hopefully, if anything you take from this, then it's that message. Thanks.
Okay, thank you very much.